Part E, effects of temperature T. In last part, we know that the length and also the cross-sectional area A and the resistivity will affect the resistance of it. Actually, the temperature will also affect it, but depends on the materials. This one will be related to the resistivity. Look at this. We have different materials for it. For the metal, increases with temperature T. Higher in temperature, then the resistivity will be higher. It means that the resistance will be higher at higher temperature. And for the other material, maybe semiconductor, will be this. Increasing in temperature will be decreases. Okay. In the microscopic view, we will not explain it. Okay, look at this one. Example 3. Okay, here we have the copper wire, and on the other hand, we have the thermistor. We will put them into different temperature of the liquid. Some of it will be hot water. The other one may be ice water, and then measure the resistance of them. Of course, we will use the multimeter to measure it. This one is the discussion. How do the resistance of the copper wire and the semiconductor thermistor change with temperature? We can notice that copper is the metal. Its resistance will be increasing with the temperature. For the semiconductor thermistor, will be decreasing with temperature. Watch this video.
Do you know how the resistance of a wire is affected by the temperature? We'll find this out using the setup shown. The setup consists of a ray box lamp connected to a DC power supply via a rheostat and an ammeter. The ammeter measures the current flowing through the tungsten filament of the lamp. The voltage across the filament is measured by a voltmeter. Start with a small current. Adjust the rheostat to increase the current flowing through the tungsten filament slowly. Record pairs of voltmeter and ammeter readings. Then plot a graph of voltage against current. Find out how the resistance of the filament is affected by its temperature.
Okay, in this experiment, you can see that this one is the rheostat, and we put the sliding contact to the left hand side. Then you can see that this one is the short circuit. The current haven't passed through the long wire. The resistance will be quite small. Then the total current will be quite large. Then you can see that the light bulb will grow like that, brighter than before. The microscopic view just only look at what is going on, then that's all. Here, this one is the metal wire, low temperature will be this case. All the atom will be vibrate. And also, because this one is the metal, we can see the electron C. At low temperature will be like that. How about high temperature? you burn it. You can see that this one will be the emitter will be smaller than before, because when you burn it, the atom will be vibrate like this, and then the electron C will be more difficult to fall through it, okay, because the collision between them. Then you can see that this one at low temperature more easy for the electron in the electron C to fall, but here for higher temperature, higher vibration will be more difficult for them to fall. It means that in a higher temperature the resistance will be higher than that at the lower temperature. Okay, how about the other one, semiconductor? For a semiconductor, lower temperature. For the semiconductor, this one actually is not a conductor. The principle for it to have a conduction will using the hole like that. Okay, at low temperature will be this case. How about high temperature? You put it into the water, then what will happen? The resistance will be lower than before. But why? Because when you give it energy, it will be more easy to have the hole, to let the electron to fill in the hole, more easy for the electron to move around it. It means that the resistivity will be decreasing, more easy for it to conduct electricity. As a result, at higher temperature, resistivity will be lower, resistance will be lower. In semiconductor. The third one will be the experiment. This one is the position of the wheel stack. Once again, try to look at it. When you move the slider, the resistance will be changed. In this case, if I move it like that, the resistance will be quite small inside the wheel stack. Current will be greater than before. The light bulb will be brighter. Okay, next part F, long ohmic device. What will happen? The first one will be the filament name, filament light bulb, 鎢絲燈膽. What will happen? Will be bent downward like that. Okay. At lower voltage, the current will be smaller. At a higher temperature, current will be higher. But you can see that the change. Even you're higher in voltage, the current will not increase a lot. You can see it from the curve. Then what happened? Look at this. Smaller I, cooler one. Okay, smaller R. But when you switch on the light bulb, the temperature will be higher, resistance will be higher. Because this one filament is also the metal. Okay, but this one is not follow the ohmic materials. Finally, we will say that this one is the long ohmic material. And how about next? Will be the thermistor. The symbol will be this one. Will be curved upward like that. And smaller V, it means that maybe the cooler case. Smaller current. Smaller current means that larger R. Next case, larger current. It means that here this one will be hotter one. Smaller R. Once again, how to know that this one is the larger arrow or smaller arrow? Look at this slope. And also focus on the axis. I is V over R. Okay, it means that slope is 1 over R. this one is steeper in slope, it means that R should be smaller. Okay. Compared with this, you can see that smaller I, smaller R, smaller I, larger R. Okay. Because when you look at this, the slope will be this. For this, slope will be this. The blue one will be steeper than the red one. But for this case, the red one will be steeper than blue one. Okay. Now go back to this example 6. Okay. Example 6, stay behind. Keep going. The other one will be the chemistry, electrolyte. For this, focus on the axis IV. It means that focus on the slope and slope. For this, steeper slope, it means that R should be smaller. Okay. Next one, diodes. 二極管. Okay. What is this? This one is a very special device. This one is also a semiconductor. You can see an arrow like that. Arrow means that if the current pass through it in this way, no problem. This one we will call it forward bias. But if the current flow it in this way, you can see that this one, to stop it, this one we will say that backward bias. What is the function or the use of diode to control the current direction? Only in one way, one direction only. In opposite direction, it will block it. Then what will happen for this diode? The characteristic will be this. This part we will say that reverse bias or backward bias. For the forward bias, it means that it can flow through it if the voltage is large enough, maybe around 0.6 or 0.7 voltage. If this one is greater than 0.6 or 0.7, then the current can pass through this diode. The diagram will be like that. Okay. And here, this one is the distinguished point. Lower than it means that maybe negative. It means that the reverse bias, or the voltage is less than 0.6 volts. Then what will happen? This diode will act as a very large resistor to oppose the flow of the current. But on the other hand, if the voltage is larger than 0.6 volt, then the current can flow it very easy. The resistance will be smaller than before. Okay, go back to example 6. This one. Look at your book. Buck resistance. Then what will happen? You can using the graph, okay, the data point in the table to plot a graph. How to describe this graph? You can say that bend downward, okay, bends downward. Here, what is the resistance of the filament when this one, the applied voltage is 4 and 12? Look at this. If the voltage is 4, the corresponding current when you look at the graph will be 1.8. You just need find out the ratio. It means that the slope of this part. Okay, once again, the slope is not the slope of this point. The slope should be this point referred to the origin. Pay attention. So this one should be 2.22 ohm. How about next? If the applied voltage is 12, the corresponding current will be 3. After the calculation, you can find that should be 4 ohm. It means that this line. Once again, this one, the y-axis is I. It means that the slope should be 1 over R. This one is the steeper one. Steeper one means that R should be smaller. Okay? Your calculation tells you that this fact. How about part C? Does the bulb obey Ohm's law? Firstly, you should pay attention on the definition of the Ohm's law. Ohm's law is this. R at different voltage are different. Not obey Ohm's law. Ohm's law tells us that resistance should be constant, even you increase or decrease the voltage. Okay, in order to prove it, you should prove that R will not be changed. But unfortunately, here tells us that R of them at different voltage are different. Okay, part D. If we have two such light bulbs connected in series, and the EMF of the battery is 12 volts, how would be the current delivered by the battery? When you look back to this diagram, you can see that both light bulbs are identical. They will share the 12 volt. It means that for each one should be 6 volt. Okay, and then based on the 6 volt, you can find out the corresponding current will be 2.28. And go back to here. This one is the series circuit. Pass through light bulb A will be 2.2. How about pass through light bulb B? Also 2.2. Okay, so the current delivered by the battery will be 2.28. What if question? If the light bulb are connected to the same battery in parallel, what is the battery? Will be 12 volt. Because they will connected in parallel, the voltage in each branch will be the same. So you can see it, this one, PD across each light bulb should be 12. The diagram should be this. The battery will be 12 volt, and then this one, light bulb, is also 12. This one, also 12. Because they are connected in parallel, they will have the same potential difference, 12 volt. Because of it, you can find it out from the graph. The current will be corresponding 3A. But now, this one is not 3A, because you can see that the current should be from positive to negative. Here is 3A. This one is also 3A. When you go to the junction, 3A in, and then 6A out. So this one should be 6A out. Remark: voltage across the light bulb increase, then go red, and then yellow. Okay, and what's the meaning red and yellow? In wave, we know that the color code, it means that from red to yellow, the temperature will be higher, because this one is the visible light. From red to violet, violet will be more energy than red one. In this case, yellow one will have more energy than the red one. This one shows us that the temperature is increasing. If the temperature increases in a metal, the resistance will be increasing. Then this one tells us that the resistance will be increasing. This one explains it. IV graph bends downward. 個燈膽隨着溫度改變而電阻改變。OK， 咁點知溫度改咗呢？因為當你俾 voltage 佢就會有能量消耗。能量其中一個消耗咧，就令到佢內能internal energy 咧提高。內能又點樣去表達呢？就睇 temperature 啦。咁因此開頭就可能紅紅地，之後就越嚟就越黃。咁即係 temperature 提高啦。當個 temperature 提高嘅時候呢，呢個係普通 metal 嚟嘅。溫度越高呢，電阻就越大。電阻越大嘅話呢，咁就發覺啦，幅圖呢就冇可能直線㗎啦。佢只會一路咁 curve， 一路咁 bend downward， 咁就 curve 落去。咁呢個就係呢個情況所話俾你聽嘅資料啦。好，最後 check point。Okay, try to watch this video.
唔知同學有冇試過用風嚟使到小燈泡發光呢？呢度有一個移除咗玻璃外殼嘅200瓦特燈泡，將呢個燈泡嘅鎢絲同埋一個小燈泡以串聯嘅方式連接至電源。 閉合電路。小燈泡並沒有發光。假如用電風扇吹住鎢絲，咦，小燈泡發光喎。同學知唔知道點解呢？而家將電源嘅電壓加大，然後閉合電路，小燈泡就會發亮。假如用火將鎢絲加熱，咦，個小燈泡暗咗好多喎。同學又知唔知道點解呢？
Okay, try to look at this part. And when we have the fan, okay, this fan will have the cool air to cool down the filament. It means that the temperature in the filament will be less than before. In the filament, you can see that if the temperature is decreased, the resistance will what will happen on it for the filament. You can look at your book. We know that this one should be curved downward. Okay, then what will happen? Temperature decreases. Okay, temperature decreases. Then what will happen? You can look at this one. When you remove the fan, it will the light bulb will not grow. It means that the current is not large enough to let it go. This one explains it. The current is less than before. The resistance of it is quite large. The filament at high temperature, okay, the resistance of it will be higher. In a lower temperature, it means that you add the fan to cool it down.
同學知唔知道點解呢？
will be smaller. Current will be larger.
而家將電源嘅電壓加大，然後假如用火將鎢絲加熱，小燈泡就會發亮。
When you start up the power supply, can you see it? The light bulb is grow to the brightest one and then dimmer than before. But why? Initially, the temperature of the filament is quite low. It means that the resistance is not very large. Current will be quite large to let the light bulb to grow to the brightest one. But unfortunately, when the current passes through it in a continuous way, the resistance of it is higher and higher because the temperature is higher than higher. Then you can see that the light bulb is dimmer.
小燈泡就會發亮。
Okay? Will be dimmer than before.
假如
And
用
then
火
when
將
you
鎢絲
heat
加
it
熱，
up again, it means that it reached a higher temperature. Then you can see that the resistance will be higher than before. The current will be suddenly dropped to lowest point. Okay, not enough to give it energy to the light bulb to grow up. Okay, this one explains the temperature effect on the wire. Of course, in this case, will be for the filament. Okay. Last session. Chapter 8. Okay, look at this. We have 5 questions. Voltage V across 2 ends of metal wire and the current is I. How does the current I change if the length is half? Okay, actually very easy. In your mind, focus on the equation. R is equal to volt resistivity times length over area A. If length is half, then what will happen? Length is half, R will be less than before. half of it, and then V is equal to IR. Okay, V is equal to IR. Okay, voltage applied on it will be no change, but R is decreasing to half, then the current will be double. Okay. How about part B? Diameter is double. Okay, pay attention. We will focus on area A. Area A, remember the formula should be this, pi r square. But what's R will be the radius. But now, diameter double. Diameter should be d over 2. d over 2 will be the radius square. Okay, pay attention on it. And the common one will be this and d square. Pay attention on the square. Now this one, R will be 1 over 4R. But why? Because when d is double, area will be coupled. Okay, 4 times. Then when you look at this one, wall area A. If area A is 1 over 4, no, not 1 over 4, is 4 times of area A, because D is double. Double square should be 4 times. If like that, you can see that will be 1 over 4 of original. Okay, this one new R will be 1 over 4 original R. Because of it, R is decreased, current will be increased. R is decreased by 1 over 4, then current will be increased by 4 times. Part C. If both of the length and diameter double, what will happen? For length double, R will be double. But if for D is double, then area will be 4 times. Okay, then this one will be over 4. Finally, you can see that the resistance will be 2R over 4. R over 2, current will be double. And lastly, if the temperature is increased, now go back to here. This one is the metal, its own material. Higher in temperature, resistance will be higher. Then R is in higher, current will be decreases. Question number 2: longer the wire or longer the length of a wire, higher resistivity. This one is wrong. Resistivity should be depends on the material. For example, copper, iron, all of them will be independent of the length. Part B. Resistivity of a conducting material should be lower than that of an insulating material. Remember it, resistivity means that the resistance of it. Higher resistivity, it means that the resistance should be higher. So this one, lower resistivity, it means that conduct resistivity better. Okay, 電阻性越低，導電性能越好。Okay, part C. The higher the temperature, the higher the resistivity of an ohmic material. Wrong. Remember it, resistivity of an ohmic material increases with temperature. Okay. This one will be the result and the effects. Okay. This one, higher the temperature, the higher the resistivity. 呢個係因果關係，而家係唔係咁講嘅，係個 resistivity 增加，係隨着個溫度增加。OK， 咁唔係呢個嘅意思，咁所以呢句嘢呢係錯嘅。Okay, question number 3. Is it a copper wire, tungsten wire, or thermistor? If this one, copper wire 銅線 ，tungsten 即係鎢絲，thermistor 即係啲溫度計電子溫度 semiconductor 嚟嘅。R increases by 50% when V increases by 10%. This one tell you that V increase, R will be increased. It means that this one is non-ohmic material. It means that this one is not a copper. And also, how about this two? Tungsten, higher in temperature, resistance will be higher. For the thermistor, higher in temperature, resistance will be lower. Then you should focus on this. You can see that voltage is increasing by 10%, but R is increased by 50%. It means that R increases with temperature. This one should be the tungsten. Okay? Or you can draw the diagram. This one is I, this one is V. Okay? For the tungsten, should be like that. Okay, should be like that. You can see that in this case, increasing R, what will happen? You can see that the slope, when you increase the voltage, the slope is not steeper one. Okay, it means that not a steeper one, R will be greater. This one is greater R, this one should be smaller R. This one tells you that exactly the same. V is increasing by 10%. R is also increasing 50%. Okay, exactly the same as this graph. This one tells us that this one should be the tungsten wire. Part B, I increases by 50% when V increases by 10%. Go back to this. Part A, focus on R. Part B, focus on I. This one should be the thermistor. How to draw the diagram of it? This one is V, this one is I. Okay, now for the thermistor, the diagram should be like that. But is it true? Try to test it. Here, this voltage may be increased by 10%. This one is 10%. But you can see that if this curve is bent upward like that, then you can see that this part, okay, this part, this change, you can see that, for example, if this part, you can see that the change will be more and more, greater and greater. Okay, this one may be only 10%, this one may be 15%. And also on the other way, you can focus on the resistance. What will happen? I change the color. The blue one. Okay, initial point, the resistance will be this. The final point will be this. Once again, steeper one should be this. Steeper one means that R is smaller than before. Okay, R decreases with the temperature. Then this one will be the thermistor, also non-ohmic material. Question number 4. For electron line, IV graph becomes a straight line beyond a certain voltage. Does it become ohmic beyond V0? The answer is no, because the ratio V over I is changing. Go back to here, this one. The diagram will be like that. Both of them are straight line. This part we can say that ohmic material because this one passed through the origin. But for this one will not pass through origin. Then this one we cannot say that ohmic material. Okay, even this one is a straight line. Okay. Question number 5 for IV graph like that. A metal wire, it means that ohmic material. That line will be the best show of it if the shorter wire of the same material, same thickness. It means that depends on error only. Shorter wire means that R should be smaller. Pay attention on the axis. This one is I. It means that the slope should be 1 over R. Okay, look at this. Shorter wire, R will be smaller. It means that this one, R is smaller. The bracket should be greater. Slope will be steeper. Okay. What are they? This one, the dashed line. the dashed line will be the final one. The final one should be steeper one. Okay? D. Can you see it? This one? Steeper one will be your final answer for part A. How about part B? Higher in temperature. Once again, what is this material? It's a metal. Higher in temperature, resistance will be higher. Then in it, we have the other formula to tell you that what happened. R should be R log. R log will be 0 degrees Celsius, and then 1 plus alpha theta. Theta means that the temperature. Alpha will be the proportional constant. You can see that the positive side. It means that when you increase the temperature, the whole bracket will be increased. R will be increased. This one tells you that if this one is metal, will follow this equation at the back end. Okay. Now this one, higher in temperature, R will be increased. Once again, R is increasing, then the bracket should be decreasing. It means that the slope should be decreasing. It means that less steeper. The answer should be C. Okay. That's all.